Okay, so for number 1, the first thing you want to do is identify the LCD. And in this case, the LCD is x plus 4 because they both have it. So we don't need to go and try to figure out, or we don't need to multiply anything. Because they have the same denominator, we can add these right away. So just like in any normal fractions that you've done before, you add the numerator. So we'd have x minus 3 plus x minus 2 all over, and then you leave the denominator the same. So now we're going to simplify, and this will become 2x minus 5 over x plus 4. And that's our final answer. Number 2 is also really nice because it also has the same denominator, so we can just go ahead and subtract these. But for all subtraction problems, you have to be careful because since this is a quantity, we need to distribute this negative. So it's actually going to turn into 3x minus 4 minus 6x minus 1 all over the denominator. Now we simplify, and this will become negative 3x minus 5 all over x squared plus 1. Since we have the same denominator, we're going to just add the numerators together, and we're going to get 9x minus 4 all over x squared minus 3. Okay, so number 4, also, both of these fractions have the same denominator. However, we need to put in our parentheses, and we're actually going to distribute the negative 3 times since we have a trinomial. Alright, so this is going to turn into 3x squared minus 5 minus 2x squared plus 3x plus 2 all over 3x minus 1. So now we're just going to add like terms in the numerator. We have 3x squared and negative 2x squared, so this is just going to give me x squared. Got rid of those. We have a 3x, and then we have a minus 5 and a plus 2, so we have minus 3 all over 3x minus 1. Okay, so number 5 is our first difficult one where we have to identify the LCD because we can clearly see that the two denominators aren't the same. And we know that when we add fractions, our denominators have to be equal. But before you do this, we need to factor. So the only thing that's factorable is this denominator right here. So what multiplies to give you negative 4 and adds to give you positive 3? Well, that's going to be x minus 1 and x plus 4. So anytime anything, numerator, denominator, can be factored, I suggest you do that right away. Now we can identify the least common denominator. Now, looking at both of these fractions, they both have an x plus 4, so that's good. Then we notice, well, the one on the right here doesn't have the x minus 1. So that's what it needs. Therefore, our LCD is x plus 4, which they both have, and x minus 1, which we need to now create them both having. Okay, so if I were to rewrite all this out, what I need to do, actually I'm not going to rewrite it, let's just do it this way. Since we identified that this is the one that needs the x minus 1, what we're going to do is we're going to multiply the numerator and the denominator by x minus 1. I'm going to put in my parentheses because I will have to distribute. Okay, so now let's rewrite and organize ourselves a little bit. Now we have x minus 3 over x minus 1 and x plus 4. We didn't change this fraction at all because the denominator had every part of the LCD. Plus, now we have 2x times x minus 1 and now we have x minus 1 and x plus 4. So now they're the same, and we just have to simplify and add like we were doing in problems 1 through 4. So the first thing I'm going to do is distribute this 2x, and that's going to make this this numerator 2x squared minus 2x. So I have x minus 3 plus 2x squared minus 2x all over x minus 1, x plus 4. And it doesn't matter if you put the x plus 4 first or the x plus 1, because when you multiply, order doesn't matter. And our last step is to simplify that numerator again, and we're going to get 2x squared minus x minus 3 all over x minus 1 times x plus 4. So there's one more thing we have to do. We're almost finished, but we have to see if this numerator is factorable. And honestly, we just want to see if it factors out to having an x plus 1 or an x plus 4, because then we can simplify like we were doing when we multiplied and divide rational functions. So it does actually factor if we did slide and divide. Let's give me more space here. If we did slide and divide, we would have x squared minus x minus 6. And then this factors into x minus 3, x plus 2. And then don't forget we have to divide by what we slid, which was a 2. So we have the factors 2x minus 3 and x plus 1. We're really close, but neither of these share or are the same as a factor of our denominator. So our final answer is just going to be this right here that we had. So we always want to check to see if the numerator can factor. Sometimes it's not going to be factorable. This one it was, but it wasn't factored into what we want. So you can leave it in standard form. You can leave the denominator in factored form. I don't care. There's no need to multiply everything out. So this is our final answer. Okay, so for number 6, we want to identify the LCD, but remember, before we identify that LCD, we need to factor. And again, we only have one factored problem down here. We have the difference of 2 squares, so we need to remember that method, and that's what we have now instead of, I'm just going to cross it out so we know to look at the factored form. So now when we talk about our LCD, it looks like we're going to have an LCD of x plus 2, which they both already have, and then x minus 2, which we know we need to add to the first fraction we have. So we're going to go ahead and do that. So we need to multiply the numerator by x minus 2 and the denominator by x minus 2. So now we have x times x minus 2 all over x minus 2, x plus 2, plus negative 8 over x minus 2, x plus 2. So now we can go ahead and we can just add the numerator. Well, first we need to distribute right here. So we have x squared minus 2x minus 8 all over x minus 2, x plus 2. So we need to see if this factors, and we want to ask ourselves, okay, what's going to multiply to give me negative 8? That's going to add, excuse me, to give me negative 2. So, okay, so what multiplies to give me negative 8 that adds to give me negative 2 is going to be negative 4 and positive 2. So let's write that out and see if it cancels with any factors we have on our denominator. So we have x plus 2, x minus 4, all over x minus 2, x plus 2. And just like before when we added and multiplied, multiplied and divided, here we go. We can cancel these out, and it simplifies all the way down to x minus 4 over x minus 2.